Partial fraction decomposition. What do we mean by that? What is the basic idea behind it? Partial fraction decomposition is the process of converting complex fraction into some other smaller or simpler fractions. Consider 5 over 6 plus 3 over 2. If we are to add these two fractions, the first thing we are going to consider doing is to determine the LCM. Since 6 is a multiple of 2, then the LCM will be 6. Now the next is to determine the amount of ways in which 6 can go in 6. That's simply 1. Then we are to multiply with this, and that will still result in 5, as 1 times 5 is indeed equals to 5. Now on this, in how many different ways can 2 work in 6? That's 3 different ways. Then we are going to multiply with this, and that will result in 9. Adding this up, we have 14 over 6, which will eventually be 7 over 3. Now, what we have done is that we have combined these two smaller fractions into a single complex fraction. Now, what if we are willing to convert 7 over 3 back to 5 over 6 plus 3 over 2? The process of we doing that is what we know as partial fraction decomposition, and that is the basic idea behind it. We have many different ways, many different cases in which you can have problem involving partial fraction decomposition. However, 4 different cases are the most common, and I'm going to list them in this video. The first case is having a partial fraction with linear factor. Example of that is something like 2 divided by x plus 1. This is an example of partial fraction with linear factor, whereby the degree of the variable at the denominator will be 1, and nothing more than that. The second case is a partial fraction with a quadratic factor. And that's a case like 2 divided by x squared plus 1. And the third case is a partial fraction with repeated roots. And when we say repeated root, we are considering something like 2 divided by x plus 1 all squared. The linear factor is repeated more than once. And the last one is improper fraction. And that is a scenario whereby the variable x will be involved in the numerator, and its degree, for instance, will be greater than the degree of variable x at the denominator. So this is an example of improper fractions. For each and every cases, there's a process at which we split them or break them into pieces. For this video, we are going to consider partial fractions with linear factor. So let's begin with some examples. We are going to go over tons of examples so that you can master the process. Number 1. Consider this proper fraction. 6 divided by x plus 3 multiplied by x minus 3. How can we decompose this fraction into some other smaller fractions? Now, for you to know the amount of smaller fractions you'll be having, that will depend on the denominator. When this is completely factorized, you consider we are having 2 different terms. Then it means you'll be having 2 different fractions that are smaller. So that's the case. So just set this to be equals to some constant a divided by the first term, x plus 3. Then this will be added. The sign is always positive in all cases. If it's going to be negative, it will change when you determine the value of b. The divided by x minus 3. Now what you want to do is that you want to multiply the both side of this equation by this. So you are multiplying everything by x plus 3, x minus 3. So what would that be? Let's see. The first case, 6 divided by x plus 3, x minus 3. Then I'm multiplying that with x plus 3, x minus 3. And that's indeed equals to a divided by x plus 3, then multiplied by x plus 3, x minus 3. And that is added to b divided by x minus 3, and it is multiplying x plus 3, x minus 3. Now we can clearly see that sometimes we cancel out. Like for this, x minus 3 cancels out. This cancels out. And for this, x plus 3 cancels out. And for this, the whole term get rid of one another. So left over is 6 equals a multiplied by x minus 3 plus b multiplied by x plus 3. So at this point, you can hold on. What you want to do next is that you want to make one of this variable to be 0 so as to solve for the other. And later on, make the initial one 0 and solve for the next one. So for me, I would like to make a 0 first. And to make a 0, this right here must be 0. And for this to be 0, I can just set it to be 0. X minus 3 equals 0. That means at x equals 3, a will be 0. And that's true. So next is just to set 6 to be equals to b plus, okay, multiply by x is 3, 3 plus 3. And 6 will be equals to 6b. And dividing 2 by 6, b will eventually be 1. I hope you got that. Now, the next case, I want to make b to be 0, so as to solve for a. To make b 0, then x plus 3 must be 0. So setting x to be equals, setting x plus 3 to be equals to 0. Then we can clearly see that x will be negative 3. And as x equals negative 3, b is equals to 0. In fact, b multiplied by x plus 3 is 0. So now we can set 6 to be equals to a multiplied by x minus 3. But the x is minus 3. So a multiplied by minus 3 minus 3. 6 equals minus 6a. Dividing 2 by 6. Minus 6 indeed. A equals to negative 1. So this is the value of a and b respectively. So what we are going to do in this case is that we are just going to set them to be this. So therefore, 6 divided by x plus 3 multiplied by x minus 3 is the same as negative 1 over x plus 3. Then plus b is 1 divided by x minus 3. And this is the answer. If you want to be sure of your answer, you can combine these two fractions by adding them. You should eventually have this. And that's how it works. Example 2. So feel free to pause the video and check this question out yourself. So just like before, let's set it to be equals to a divided by the first term, which is 2 plus x, plus b divided by the second term, which is 2 minus x. Having done this, we want to enclose them within the closed bracket and multiply everything by 2 plus x, then 2 minus x. To keep things short, I won't expand this bracket, but just cut straightforward. For the first part, which is this, I'm using the green color. 2 plus x multiplied by 2 minus x will cancel 2 plus x multiplied by 2 minus x. and left over will be x. Then we have the equal sign. At this portion, I'm using the red color. 2 plus x cancels out 2 plus x. Left over is 2 minus x. And I'm having a multiplied by 2 minus x. And for the last part, I'm using the yellow color. 2 minus x cancels 2 minus x. And left over is 2 plus x. Plus b multiplied by 2 plus x. I think this sounds good. So now, I want to make it either a or b to be 0. So let me begin with a. To make a to be 0, then 2 minus x has to be 0, and x has to be equal to 2 by the time we add x to both sides. So left over will be x equals b multiplied by 2 plus x. Since x is equal to 2, x will be equals to b multiplied by 2 plus 2. And this also has to be 2. So that will be 2 equals 4b. Dividing 2 by 4, b will be equals to 1 over 2 by the time we reduce this. Perfect. Now what about a? To determine the value of a, let's make 2 plus x equals 0. And x will be equals to 2. But minus 2 indeed. So now let's solve for a. So x will be equals to a in the bracket of 2 minus x. So since x is minus 2 will be equals to a multiplied by 2 minus 2. And that will be minus 2 equals a multiplied by 2 plus 2. And eventually, let me just write that over here. That will be minus 2 equals to 4a. And dividing 2 by 4, a will eventually be minus 1 over 2. So b is 1 over 2 and a is 1 over 2. So now we can write our final answer. Let me just write a over here and get rid of all the stops. So finally, x divided by 2 plus x multiplied by 2 minus x will be indeed equals to negative 1 over 2, or divided by 2 plus x, then plus 1 over 2 divided by 2 minus x. So we can't leave our answer this way, we need to rearrange. And to do that, we need to use the concept of keep, change, and flip. So our final answer will be minus 1 divided by 2 multiplied by 2 plus x, then plus 1 divided by 2 multiplied by 2 minus x. Don't expand the bracket, just leave it that way. We have been able to split it into 2 other smaller fractions. And that is the solution to this problem. Number 3. X minus 1 all divided by 3x squared minus 11x plus 10. You might be thinking that this is a case of improper fraction. However, it is not. You have to be very careful before you judge. First, you have to check, is that denominator, is it factorizable? If it is, then you can just conclude. But if it is not, that is when you can conclude. So, let's see if it is factorizable. Can we get any two numbers that multiply to 30 and add up to negative 11? That should be negative 5 and negative 6. As negative 5 times negative 6 is 30, and negative 5 plus negative 6 is negative 11. Perfect. So now let's move on. So let's factor it out. So that will be negative 5. That will be x minus 1 all divided by 3x squared minus 6x minus 5x plus 10. That will be x minus 1 all divided by 3x in the bracket of x minus 2 as a common factor, minus 5, then x minus 2. And that will be x minus 1 all divided by, combining this, that's 3x minus 5, then multiply by x minus 2. So this is the factorized part of this given denominator. So now we can break it in pieces using partial fraction decomposition. So we have converted to x minus 1 all divided by 3x minus 5 then multiply by x minus 2. So since we're having two terms at the denominator, then we'll be having two constants. That's just a divided by 3x minus 5 then plus b divided by x minus 2. So let's enclose that. We are multiplying everything by 3x minus 5 multiplied by x minus 2. So now just like before, I'm using green color to cancel this. So that's 3x minus 5 multiplied by x minus 2 cancels out. And for the red color, 3x minus 5 cancels out 3x minus 5. And left over is x minus 2. So x minus 1 equals a multiplied by x minus 2. Then we have the positive sign. So for the yellow color, x minus 2 cancels out x minus 2. Left over is 3x minus 5. That b multiplied by 3x minus 5. So now, let me try to make either a or b 0 in the first place. So to make a to be 0, or let's say this whole term to be 0, x minus 2 has to be 0, and x has to be equal to 2. At x equals 2, then x minus 1 will be equals to b multiplied by 3x minus 5. And substituting 2 for that x, 2 minus 1 equals b multiplied by 3 times 2 minus 5. And that will be 1 equals b multiplied by 6 minus 1 minus 5. My bad. And eventually, 1 will be equals to b, because 6 minus 5 is b, and b is indeed equals to 1. So what about b? How can we make this whole term to be 0? Just like before, let's set 3x minus 5 to be equal to 0. Adding 5 to both sides, 3x will be equals to 5. Just like bringing 5 over here, okay? Then dividing 2 by 3, x will be equals to 5 over 3. So definitely at x equals 5 over 3, this whole term is indeed equals to 0. With that, we can clearly solve for a. As x minus 1 will now be equals to a multiplied by x minus 2. But x is 5 over 3. So we have 5 over 3 minus 1 equals a multiplied by 5 over 3 minus 2. So let's solve that. For this, combining this, that will be indeed equals to 5 minus 3 over 3. And that will be equals to a. Now what about this? That will be 5 minus 6 over 3. So I really don't have enough space anymore. Let me get rid of this. I don't need that anymore. So 5 minus 3, that's 2 over 3, equals to a multiplied by negative 1 over 3. How I got negative 1? That's just 5 minus 6, that's negative 1. So multiplying that will be 2 over 3 equals negative a over 3. Then cross multiplying, we have negative 3a to be equals to 6. Dividing 2 by negative 3, then a will be indeed equals to negative 2. And that's the value of a. b is 1, a is negative 2. Now that we have all that, we can get the partial part of the fraction. So therefore, x minus 1 all divided by 3x squared minus 11x plus 10 can be split into negative 2 all divided by 3x minus 5, then plus 1 divided by x minus 2. And this is our final answer. I hope you grab that. Now let's consider more complex problem. Now what about this? Feel free to pause the video And figure this one out yourself. 3x plus 1 all divided by x plus 2, then x plus 1 and x minus 3. It has been factored already, so we can just substitute. Keep in mind, we are having 3 different terms at the denominator right now. So we are having 3 different constants. A divided by the first term, x plus 2, then plus b divided by the second term, x plus 1, then plus c divided by the third term, x minus 3. Then we are multiplying everything by the whole denominator. So I'm just going to reduce this a little bit so we can have enough space. Perfect. So we are multiplying that with x plus 2, x minus x plus 1, then x minus 3. So just like before, let's use some colors to cancel out. So starting with the red color. On the left hand side, the whole term cancels out, and left over is 3x plus 1. Then we have the equal sign. So now on the right hand side, using the yellow color, x plus 2 cancels out, x plus 2, then left over is x plus 1 and x minus 3. So that's a multiplied by x plus 1, then multiplied by x minus 3. Then we have the plus sign. Now what about b? That means blue color. X plus 1 cancels out x plus 1, and left over is x plus 2 and x minus 3. So b is x plus 2 and x minus 3. And for the last one, that's c. So for c, I'm using green color. So x minus 3 cancels out x minus 3, and left over is x plus 2, x plus 1. Perfect. So now, we want to make either a, b, or c to be 0. What should we do? What number should we substitute? To make a 0, one of these just has to be 0. Because one of them is 0, then this whole term will in fact be equals to 0. So let's see. All we need to do is to set x plus 1 to be equal to 0, and x will be equal to negative 1. So at x equals negative 1, this whole term will be 0. And this whole term will still be there. So that's just plus b multiplied by x plus 2, then x minus 3. But fortunately, this whole term will also be 0 because we have negative 1 plus 1 right here, which will be 0, and which will cancel out everything over here. So that has gone as well. So that will be equals to 3x plus 1. So since x is minus 1, we have 3 multiplied by negative 1 plus 1 equals b multiplied by negative 1 plus 2, then multiplied by negative 1, negative 3. 3 multiplied by negative 1 is negative 3 plus 1 equals negative 1 plus 2, that's b, then multiplied by negative 1, negative 3, that's negative 4. Negative 1, negative 3 plus 1, that's negative 2 equals b multiplied by negative 4, that's negative 4b. Dividing 2 by negative 4, b equals to 1 over 2. And that is the answer to b. So let's write this somewhere so we won't forget. Jot it down. B equals 1 over 2. I've written mine down as well. So now the next is to solve for a. Okay, we have make c and a 0. Now let's solve for a. To solve for a, this and this has to be 0. So what should that be? Let it be x plus 2 and x plus 2. So we are setting x plus 2 to be 0. So x will be equals to minus 2. At x equals minus 2, this term is 0 and this is 0. Why? Because we are having a term x plus 2 there, and minus 2 plus 2 is 0, minus 2 plus 2 is 0. And that cancels out. Perfect. So now we should be left over with 3x plus 1 equals a multiplied by x plus 1, then x minus 3. So if we plug in negative 2, we have 3 multiplied by negative 2 plus 1 equals a multiplied by negative 2 plus 1, then multiplied by negative 2 minus 3. 3 times negative 2, that's negative 6 plus 1 equals a multiplied by negative 2 plus 1, negative 1, multiplied by negative 5, because negative 2, negative 3 is negative 5. Minus 6 plus 1, that's minus 5, equals negative 5 times 5, that's plus 5a. Dividing 2 by 5, we have a to be negative 1. So a is indeed equals to negative 1. Perfect. Now on to c. To determine c, we need to look for the term that is similar in a and b. So what should that be? That would be x minus 3, x minus 3. So setting x minus 3 equals 0, x equals 3. At x equals 3, this is 0, this is also 0. Because we have 3 minus 3, that's 0. 3 minus 3, that's 0. Perfect. So now we should have 3 multiplied by x plus 1 equals c multiplied by x plus 2, then x plus 1. So x is 3. 3 multiplied by 3 plus 1 equals c multiplied by 3 plus 2 multiplied by 3 plus 1. And that will be 3 times 3 is 9 plus 1 equals c multiplied by 3 plus 2 is 5, 3 plus 1 is 4. And 9 plus 1 is 10. C multiplied by 5 times 4 is 20. Dividing 2 by 20, C is indeed equals to 1 over 2. Unlike B, C is also 1 over 2. So now we can write the final statement. So therefore, 3x plus 1 all divided by x plus 2, then multiplied by x plus 1 multiplied by x minus 3 will be indeed equals to, so a is negative 1 all divided by x plus 2 plus 1 half, which is b, divided by x plus 1, then plus 1 half, which is c, divided by x minus 3. So finally, we have negative 1 over x plus 2 plus 1 divided by 2 multiplied by x plus 1 plus 1 divided by 2 multiplied by x minus 3. Once you're having a fraction, just bring it to come and meet the denominator. That will be the final answer. Hopefully you find this content helpful. If you haven't subscribed, please do subscribe to my channel. Thanks for watching. See you guys in the next video. Now you know how to decompose complex fraction with linear factor into simpler fractions. Thank you. Bye for now.